All right, so we just learned what trend lines or lines of best fit were. Now we're going to talk about, well, how can we use them given data? So let's dive right on in. So this example here is several slides, but it's because I want us to talk about important thing. We're gonna, anytime you're given years, adjust the years, and whatever your beginning year is going to become year 0. So this is our years since 2000. So 2000 down, right? So 2001, 3, 4, 7. So here we have 1, 3, 4, 7, 8, 9, and 10, because those are how many years from 2000 that we are working with. So again, we just took the table and we changed the years to how many years since 2000. So that's how we created this table. From there, they have a scatter plot for us, and this shows the worldwide movie ticket revenues for top grossing movies for several years. The scatter plot suggests a linear association. And then if you notice, it says years since 2000. So we know that we just add these numbers to 2000. We want to find a trend line to represent the data. So we're going to draw a line to the best of my ability. So be up here somewhere. Okay, sorry, I'm just trying to figure out how I'm wanting to sketch it. So there's my attempt at a sketch, and then we're going to pull 2 points. I'm going to be honest with you, I have these points pulled from the example. Not that this is too far off, because I was pulling point 2, 8.6. So this is 8, 8.5. So we're not far from 8.6. And 9, 10.4. Again, not too far off. If I have to do it for my own lines, I'm probably going to pick something like this line here, where the 6, 9.5 are, because they're at those whole number points. But again, I just took this from the example, and I wanted the example to come out similar. A lot of times in Math Excel, it's going to give you a scatter plot, but if you read, and I know a lot of us hate to read the paragraphs, but if you read the paragraphs, most of the paragraphs will give you 2 points for you to use to write the equation. So we found our trend line, so A is done. So now we need to write the equation for our trend line. So like I said, I'm using the points 2, 8.6 and 9, 10.4. And those were chosen for me because of the example. First I need to do is find the slope. So I'm going to do 10.4 minus 8.6 over 9 minus 2, which is going to give me 1.8 over 7, which is not equal, but approximately 0.2. From here, we're going to plug in. I'm going to use this first point here. So these are my x and y. So my y is 8.6 equals my slope, which is 0.2, times 2 plus b. And we're going to find b now. So 8.6 equals negative, or 0.2 times 2 is 0.4. Plus b, get b by itself, so we're going to subtract both sides by 0.4, and we end up with 8.2. So b is 8.2. From there, my equation would then be that y is 0.2x plus 8.2. That's my equation. All right, so from here, I rewrite this equation over here. Here's that equation again that we just made. We have 3 more parts to talk about. So it says, about how much would you expect the top grossing movie for 2002 to make in total revenue? So first I need to realize that 2002 is 2 years since 2000. So x is 2. And I just plug in for x. So y will equal 0.2 times 2 plus 8.2. So y would equal 0.4 plus 8.2, which would give us a y that is 8.6. Now for what we're doing, that would be $8.6 billion. Oops. Just need the in. All right. So if they are giving us an x value, we plug into x. D is giving us a y value. How do I know? Because I read, in what year would you expect the total revenue for the top grossing movie to be? About 9.5 billion. And so that's total revenue. So this is a y value. So I'm going to plug in for y and solve for x. So we have 9.5 equals 0.2 x plus 8.2. Subtract 8.2. 9.5 minus 8.2 is 1.3 equals 0.2x. We're going to divide by 0.2. And we get that x is approximately 6.5, well, is 6.5, which is approximately 7. So 7 years, and so 2000 plus 7 years would be approximately 2007. So how does our answer in part D compare to the data collected for revenues? So in 2007, we say that's when we're close to the 9.5 billion. So here in year 7 is 9.7. So how does our answer compare? So the actual data was $9.7 billion. So it's not exact, but it is a reasonable estimation. And so those are the types of reasonings we're looking for, because you're not typing in those things, you're choosing. So that's kind of what you're looking for there. All right, last example. Scatterplot shows the average ticket prices for movies for several years. Scatterplot suggests a linear association. The equation of the trend line is, most of your math excels for this lesson are going to give you your trend line. If they don't, they're giving you 2 points for you to find your trend line. How much will a movie ticket cost in 2020? So 2020 is 20 years since 2000. And I know that's years since 2000, right? You guys have it easy. I was having to work with like 1980, 1970, and I had to do subtraction to figure mine out. Yours all start from 2000, and so it's whatever number comes after it. 20 years. So then we're going to plug into this equation. Y equals 0.3 times 20 plus 5. And 0.3 times 20 is 6 plus 5. 6 plus 5 is 11. So it is 11, I'm guessing, $11 billion. And not just $11. All right, so that's the first one. Then the second one says, when did the average movie ticket cost $6 billion? It was movie ticket prices. Say, Mrs. Cartwright, you're going crazy. That's not $1 billion. All right, approximately $11 in 2020. Makes more sense that way. When did the average movie ticket cost $6.50? So that means I'm going to plug in $6.50 for Y, because this is my Y value. And I'm going to set that equal to 0.3x plus 5. So we're going to start by subtracting 5, because I want to zero out my constant. So I end up with 1.5 equals 0.3x divided by 0.3, not x, Mrs. Cartwright's starting to write like the students. And 1.5 divided by 0.3 says that x is 5. So that means years. And so when did the average movie ticket cost $6.50? According to this, it would be 2005 is when that would happen. And we can double check. Here is 2005. And it was approximately 6.41, which is truly not far from 6.5. And that is how we use scatter plots to find information, and our trend lines and all of that lovely stuff. So until next time, 8th graders, be good.